many times do I see 3, 2, 1, and then it does. I don't know why that bothers me, but these little things that bother me, I just can't handle it as an old man that I am right now. See, I'm almost dying. All right, number one. We have three different cases. Now, it's not going to be clear until, let me move my fat head up here. All right, here we go. I have three cases. I'm not going to cover these three cases like why until we get down to here. And I'm actually going to do a little calculus thing. Well, I'm glad a calculus teacher isn't in here because I won't probably do it perfectly, but it is exactly what's going on here. And here's what we're going to have for horizontal asymptotes or oblique ones. By the way, input, output. This is in theory, if I could plug in, if I could plug in infinity, what would I get as an output? Or if I plugged in negative infinity, what would I get as an output? That's what an end behavior asymptote answers. How is this going to end when I'm plugging in big numbers to the left? No, to the right and to the left on a graph. All right, with rational functions, it gets pretty special. Like, for instance, one thing that's really special is if the degrees are equal, I'm going to prove this when we have this down in our equations below. Then you are actually coming to a constant, some special number. Whoa, that's crazy. I plug in infinity and the output value is a number, a concrete number? Yes, it is. And I tried to explain it further with first, but we don't have an equation yet to make sense out of this. All right, and then here's what happens when the degree of the numerator is smaller than the degree of the denominator. Are you telling me when that happens, when I plug in infinity, the output is 0? And the answer is yes. That's what these mean right here. This means this is synonymous with if I plugged in infinity for a number, I'd get 0 as an output. Whoa, mind blowing. Both plus and minus. This one is saying if I plugged in either plus or minus infinity, I'd get a number, a concrete number, C. So that's what these limits mean. Limits mean approach, not actually happen, because I can't come up with the number infinity. It's an idea. All right. But if that idea holds true, then I would get that as an output value. And then these say, okay, case number 3, when the numerator's degree is bigger than the denominator, when I plug in infinity, it really depends. Then this is what most people would expect. I'd get plus or minus infinity. So actually, you could put in both cases. It could be any of these 4 cases. It depends on the graph, and it depends if it's flipped, how it ends. And that's what most people would think everything works like, not with rational functions. Rational functions have different cases. So this is synonymous with this as well. That's synonymous with what the equation of the horizontal asymptote is. This is synonymous with what the equation of the horizontal asymptote is. The third case is when you get, we're really just going to do slant asymptotes, but in the future, I'm going to show you not even slant asymptotes. You could have quadratic asymptotes. You could have cubic asymptotes. And you'll see that when I, maybe go to the graphing calculator when I see fit, when it fits in what we're doing. I don't know what just happened there. Okay, so let's look at this first one. And I did this like a calculus idea is, and I think the best thing to do is this. Watch this. This is going to be wild. This is what they do with limits a lot of times. I have a calculus student that comes into 6B tutoring, and it reminds me that they do things like this. I can multiply the top by something as long as I multiply the bottom by the same thing. You know that, right? That's how you get a common denominator. So let's multiply by 1 over x, 1 smaller than that x squared, 1 over x. You may see yourself doing this in calculus next year. And if I distribute this, then this becomes 6 over x for this term. Oh, and I forgot to ask you a question, but I guess it's okay. What's 1 over x times negative 2x? What happens? What do I end up getting? It's just negative 2. The x's cancel. This is why I chose 1 over x. All right, but then I really chose 1 over x because I wanted this left over. What's x squared times 1 over x? That's x. This is the key. This is the big one. This is why I left this here. And then this is minus 1, And then this is minus 6 over x. All right, now here's what we're going to do conceptually. I'm going to plug in infinity. What? I'm going to plug in a really, 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 really large number. What's 6 over infinity become? That's what I didn't ask. What does 6 over infinity become? 6 over 1,000, 6 over 100,000, 6 over 1,000,000, 6 over 1,000,000,000, 6 over 1,000,000,000,000. What are those numbers getting closer and closer and closer to as I throw in bigger numbers? 0. So actually, when I do f of infinity, this becomes 0 minus 2. I have nothing to plug in for the 2. So that becomes 2. But then look at the bottom. What's x become? What did I just plug in for x? Infinity minus 1 minus 0. That's what 6 over infinity is again. So the numerator is negative 2. The denominator is infinity. Yet again, what is negative 2 over infinity? I just asked the similar question up here. What's negative 2 over infinity? 0. So this function, when I plug in infinity, I get 0 as an output. Now, you want to get nuts? Let's get nuts. Let's plug in negative infinity. The only thing that changes is this. That's the only thing that changes. What's negative 2 over negative infinity? Still what? 0. So on both ends, when I plug in big numbers, both positively, you really shouldn't say big numbers negative, the bigger the negative, the smaller it is, right? You're approaching 0 on both ends. So that is why, what does it say for me to do here? You know what, I'm not going to do this till the end. If the function has removal, but we'll do that on the next one. We'll do that on the next page. I want to focus on this thing. I want to focus on the end behavior asymptotes because this is a brand new concept. Now, is this going to be on the test? Not doing this. I just wanted to. You're in BC. You're going to going into calculus. I don't know how many A/Bers will. A handful. I want you to know how limits are sometimes analyzed. They're analyzed by that concept. What I did there, multiplying by 1 over x, and then what conceptually happens when I throw in big numbers. But anyway, that's what we got. We have a horizontal asymptote at y equals 0. That means my limits will be as x approaches infinity, y approaches 0. As x approaches negative infinity, y approaches 0. And that's what's going to happen with that. But we have a lot to do, so I'm going to skip, and I'm going to move to this one. All right, I'm going to move to 3 because this is our second case. Okay, but you know what I'm going to choose to divide by or multiply by? These are x squared equally on the bottom and top, so I'm going to multiply top and bottom by 1 over x squared. This is a calculus kind of thing to analyze stuff. We used to do it in pre-calc at the end of the year. We used to do, it doesn't matter, I'll just shut up. 1 over x squared times x squared is 1, right? And then 1 over, or 3x over x squared is 3 over x. And actually, I don't want this. I'm going to erase that. What am I going to plug in there? Infinity. Okay. And then this becomes 2 over x squared. And then this becomes 4. Hey, what happens when I plug in infinity? What do I end up getting? 1 plus 0 plus 0 over 4 conceptually. What do I end up getting? 1/4. Now, this is what I tell I don't know if this really, I worry about my A/Bers and showing them stuff. They're really robotic, and then they'll start trying to do this on a test. And then, no, I was trying to climb into your head. So with them, I just told them, hey, what happens when I plug in 1,000? What's 1,000 squared? What's 1,000 squared? It's 1 with 6 zeros, which is what? 1,000,000. And you know what happens? The bigger the numbers I plug in, the numbers that have lower degree in that polynomial become irrelevant. They really don't really matter anymore. So you kind of ignore them. And then what happens when I plug in 1,000? What's 1,000 squared times 4? 4,000,000. What's 1,000,000 over 4,000,000? Yet again, the same answer. What is it? 1/4. That's what I tell them. But I don't know if they get it. I had to teach this Monday, Tuesday, Wednesday, Thursday, Friday, and then Monday, and then what's today, Tuesday? I had a quiz and I had the first question, what's the horizontal asymptote? And half of them got it right after 6 days. I'm doing the same thing. And then, can I even retest? I didn't get it. I did it for 6 days. What do we have, 6 more days before you learn what a horizontal asymptote is? Boom. Thanks for listening. Did I say good afternoon, by the way? Yes, thank you. Does it, wow is right. Wow is right that I have to deal with this. Hey, when I throw in a negative infinity, what happens? Same thing. Okay, you still get 0. How are your nails over there? One girl going, oh, I got a cuticle right here. All right, anyway. Okay, so now the horizontal asymptote's y equals a fourth. Okay, so that's what that C value is. Here we go. Put this in big blue. Hey, let's write this in blue. I don't have a blue pen. Whatever. 1/4. So whenever these are equal, stop making that noise. When those are equal, it's the coefficient in front. But it's all about input, say it. Do I have to ever do this? No, it's conceptual. Okay, now let's look at these, one of these two. They're about the same. Do you notice what the similarity with g of x and m of x is? The numerator's degree is what? Bigger. So you know what I do on this? I do the 1 over x thing. I go 1 less than the numerator, or 1 less than the highest degree, just to see what's happening conceptually. And this is equivalent. This becomes 3x. This is plus 2 minus 1 over x. 6 days of the same concept. I don't get it. I don't know what to tell you. You make me cry. Minus 4 over x. Okay, gotta lock in. Hey, you know what happens when I plug in infinity? I end up getting, what's 3 times infinity? What's 3 times infinity? Infinity plus 2 minus 0 over 2 minus 0. Okay, fine. What's infinity plus 2 divided by 2? Still conceptually. Infinity. This actually ends up equaling infinity, right? And then if I plugged in a negative, then it does. You don't have to worry about this part. The only thing that changes is this, which that would be a negative infinity. That tells you what happens on the ends on this one. So this becomes what's called a slant asymptote. And then I actually just have to tell you how to find this later. The notes aren't greatly constructed right now for slant asymptotes, but I am going to find one on the next page. Okay, and the reason I know it's a slant asymptote because these differ by 1 degree. That means we have an asymptote with an x in it, with a slope, something x. Okay, and then you'll see this on the next page. Trust me? Okay. All right, so anyway, that's the conceptual idea. Okay, identify the discontinuities for each function. This is yesterday. This is yesterday stuff. If it's infinite, state the equation of the asymptote. If it's removable, state the whole of the ordered pair. But then it's the new stuff today. B, state the horizontal or oblique. We're actually going to find an oblique if we have it. Oblique is slant. And then fill in the table at the bottom matching the function. This can be kind of hard because for no purposes, I got to show the whole thing. So I'm going to come up here and do it. And then hopefully you can look at your paper. But let's break this down. So letter A is vertical asymptote. Come on, from yesterday, what's the vertical asymptote? X equals what? -3. Okay, now this is what I tell my students in the regular but they struggle on this, and then they were getting their pieces of paper out after 6 days. What's the rule? And then they're just trying to read the rule. When all it is what happens when I plug in infinity. What's 1 over infinity plus 3? What's the answer to that? What's 1 over infinity? 0. So my y equals asymptote is y equals 0. Because the ends are going to be controlled by that idea, that output idea. All right. And when I plug in negative infinity, you are going to get 1 over negative infinity, which is a negative number, but it's so small it's still almost 0. That just tells you where you're at compared to that asymptote, which is later when you have to graph, making sense out of stuff. So that's what I tell them. This is, you just got to do it. And then what was letter C? Match down there, right? No, we're not going to do that yet. We'll do that at the end. Okay, next one. Here's always step one when you're graphing rational functions, which is what we're getting to. I do kind of like this approach, like getting the components first, having these discussions. By discussion, I mean I just talk at you. All right. Anyway, and then when we graph, we know all the components we need to put a graph together. First thing you got to do is factor, and then isn't that x plus 1, right? And then on the bottom, we got that classic difference of two squares. Oh, I yell at them. If you still don't know how to graph a difference of two squares, A, you make me really sad. B, I don't know what to tell you. Okay, right? What does that mean we have? A whole. So hopefully I didn't. So this is letter A, right? Letter A is find all those discontinuities. So let's say the whole first. So what is the whole? It is that zero of that. Hey, let's put that in blue because I canceled it in blue. The zero of x plus 1 is negative 1. But then what do I do with that? I plug it into the leftover. What's negative 1 times negative 3? 3. What's negative 1 minus 1? What's negative 1 minus 1? Negative 2. So let's just make the whole thing negative. And then maybe put that back in red for the closure of this. But then I still have this. Do I still have a vertical asymptote? Well, he's writing this, so he must. What's the vertical asymptote? X equals, if you don't, I heard someone say 1, you're gone. I'll mark you wrong so quick your head will be spinning if you don't write X equals. Now I have horizontal asymptotes, which are Y equals. And I guess I kind of went over that pretty fast, but horizontal lines are Y equals. Vertical lines are X equals. So letter B is there a Y equals? And is there? Well, input. These are irrelevant because they're smaller in degree. So let's just analyze the first part. If I plug in 1,000, let's ask this one more time. What's 1,000 squared? 1,000,000 times negative 3. Negative 3 million. Over 1,000,000. What's negative 3 million divided by 1,000,000? Negative 3. That is why when I plug in infinity or negative infinity, my outputs approach negative 3. So I don't have to do that 1 over x squared thing or 1 over whatever, right? It's what's happening, all right? And that's why I wanted to show you that. Okay, good. And I think that's all they asked you to do. Then we'll match something later. Hey, you'd be smart to make a negative or take a negative out of that numerator and flip around the minus signs because you can see the bottom. The bottom is x minus 5, x plus 5. Is there a hole? Yes. Okay, so I'll just do this now. Boink. All right, and then A is a whole at 5 comma. What's the 5 comma? Come on, look at what's left over and plug in 5. What do you end up getting? Negative 1 over 10. I can't. Where'd you get that from? What are you doing? I'm half paying attention. I lick the walls every once in a while during the notes. 5 plus 5 is 10 on the bottom. Okay? All right. Do I still have a vertical asymptote? I should have put whole. Do I still have a vertical asymptote? I heard someone say no. Yes, vert SE. And that's at x equals negative 5. Right? And then we'll match the graph and then limits that go with it. So it is a good way of doing it. It's just kind of a large paper here, and it's hard for me to kind of zoom this in. I'm gonna go in reverse order too. After I'm done with 6, I'm gonna match 6, then 5, 4, 3, 2, 1. And then B, what's the horizontal asymptote? Hopefully we know it at this point. Y equals 3, 2, 1, go. Oh, nobody knows. Nice. Y equals what? I heard some people whispering it. It starts with a Z. Are you confident on 0? How many people are confident with the 0 there? It's because 1,000 over 1,000,000. It'd actually be negative 1,000 over 1,000,000 because if I threw in 1,000, that's negative 0.000 something, right? But then if I plug in 1,000,000, then it's 1,000,000 over a 1 with 12 zeros. Is that a trillion? I don't know what 1 with 12 is. Is that a trillion? Yeah, 9. 9 zeros is a billion, so it's a million over a trillion. That's 0.0000000 number. The bigger the number I plug in, what am I getting as outputs? 0. Okay, that's what we have to understand there. Got it? Next. This doesn't factor. I don't have a hole. Let's just get it over with. X equals 0 is our vert ASCII because I can't have a 0 in the denominator. Now we got a problem. I told you letter B, or told you in these questions, when I plug in infinity, I get infinity. That means there's the graph's going off into infinity or negative infinity, but there is a control. And the control is this: to find a slant, and this is a slant because the numerator is off by 1 compared to the denominator, you actually physically divide the two. And then what you're left over with is what the slant asymptote is. Got it? So to find a slant, it wasn't really ready to do up there, and I just wanted to cover it on this one. And then we'll see it in the picture. We'll actually see it in a picture that matches with this. Don't blow a brain gasket. What times x equals 2x squared? What's the answer to that? 2x goes up in the top, and then you only have one multiplication to do, and then subtract. Gone. And then you bring down this 2x. What times x equals 2x? What's the answer to that? 2. 2 times x is 2x, and then you subtract, and then guess what minus 9 is? What's negative 9? The remainder. So it's just 9 over x. Now, here is your slant asymptote. Listen, this is control at the end of the graph, both left and right. So I'm plugging, it's the idea if I plug in infinity, what are my ends looking like? When I plug in infinity, 9 over infinity is 0. So this is what they commonly do. When you're writing a slant asymptote, they couldn't care less about the remainder. Time for a drink. Did anyone hear what I just said there? Not the time for a drink thing. When I plug in infinity, this becomes irrelevant. Now I'll tell you what, if you're in a written exam and you wrote that part, I don't think it's wrong. Okay, but that's the point of that. It doesn't really matter. So say hello to your slant asymptote. Say hello. Hello. Okay, that's what you got to do. Are you okay? Are you mad or cold? Okay. Next one. Listen to them out there. What's the vertical asymptote? Because I don't have anything that cancels. What's the vertical asymptote? X equals 1/2. Okay, now we're talking here. What's the horizontal asymptote? Because I have equal degrees. Y equals what? Oh man, we're not getting this. If I plug in 1,000, I get 7,000 over 2,000. This is irrelevant. What's 7,000 over 2,000? 7 over 2. And why do I keep picking 1,000? Because it's a big enough number to get the concept down to make -1 insignificant. Anyone hear that? Yoda laugh? He just got a text. Okay, let's move on. And then, you know what I should do on this? I see what the future is, and the future is bright. But also I see that I want this to factor to, like kind of look like this. So whenever I see these reversed, you should actually get that -1 out of there and then factor that difference of 2 squares. So if that said x minus 3 on the bottom, we'd be in trouble if we didn't do that. We might misidentify things. But I don't. This one's weird. Okay, because you're going to overanalyze this if you're a robot. If you're robotic, I'm like, this is the rules and this is what I got to do. Right? First of all, do I have a hole? Yes or no? Yes. So the hole is located, hole, let's make that an H, hole. Whenever those cancel, that's a hole and it's -3 comma, okay, H. And then plug it in. What do you get when you plug in -3? Careful. -3 minus 3, but then times -1. 6. And then, do I have a vertical asymptote anymore? There's nothing else in the denominator. As a matter of fact, You should already be able to look at your graphs at the bottom and know what this is a picture of. What is that a picture of? What's y equals negative x plus 3? I went ahead and distributed this back in my mind. What's y equals negative x plus 3? A line. So do I go here and say there's a slant asymptote? There's nothing even to divide anymore. There isn't. I mean, the slant asymptote is how the graph ends is the graph. The graph is a line. So there is no slant asymptote because this is not a rational function anymore. The whole just is an interruption in this linear graph. So I don't really robotically do that. So as a matter of fact, that's why I'm going to go to this and then go to the screen, because I can't really do this any other way with the size of this. Did we do this yesterday? Is this us? And then when I go away, see how it's like really white, then I go away and do you see that? See how that changed? I didn't even see that. Then I put my face here, and then it goes all like that. That's weird, isn't it? Is that just me? And maybe not. All right. Anyway. I always say these things. I look around and people look like, this guy is so weird. Looks. Let's move this over here. Let's maybe choose a different color. I choose green. Do I? There we go. Shh. All right, now, where do you see a line with a hole at negative 3 comma 6? Which letter? Which letter? D. I mean, come on. This is a D. This is a D. There's that hole, negative 3, 6. All right. And then there's y equals negative x plus 3. Y-intercept of 3 and then down 1 over 1. Down 1. If you don't know how to graph a line, there's the door. Okay. So that's why that's letter D. Oh, I didn't go far enough. Let's see if I can. No, I can't. All right. Let's do it this way. Okay. This is why this is so hard to do, because you can see, but I gotta zoom all the way out here so I can match the notes here for you and be your teacher. Okay, so then how does this end? Input, output, input, output, input, out. Where are my y's going as I plug in big x's? Where are they going, everyone? What's that answer? Negative infinity. Oh, I forgot this is, darn it. So I have to redo this and then go back to this. I forgot it doesn't do the thing over there. Then I'm going to move this over here. Then I got to select, and then I get select green. It happened again, and now I got it. And then this one was this one, because of the hole, and then and down and over, so that's D, and now we got this. Okay, as x goes to infinity, here's where y goes. That's how you analyze this. As x goes to negative infinity, where's y going? Where's that going, everyone? Positive infinity. I don't know if I could see that writing in there. Can I? Can I? Yeah, that's good enough. All right, just want to make sure this happens. So, which one of these limits is this? Which one is it? Is it I or the 6, V1? It's 6. It's this one. And I'm going to cross these off when I'm done. So that's V1. I first mistaken and thought that was Roman numerals. It's not. It's just I, blah, blah, blah. All right. Next, let's go backwards. Where do I see a vertical asymptote of x equals half and y equals 3 halves? Anyone know? Take a guess. A, B, C, E, or F. Which one? Which one has the horizontal asymptote y equals 3 halves? No one's saying anything. Which one is it? You know, y equals is a horizontal line, right? So which letter is it? I heard someone say it. Isn't that y equals 3 halves right there? See how the graph is behaving right there, right? And then x equals a half. Isn't that right there, right? So you got to know vertical lines are x equals and horizontal lines are y equals. What's the matter? 7 halves is 2 times 3 is 6. That's 3.5. Right? I'm freaking out here. What did I say? I said 3 halves? Oh, my bad, dogs. Anyone? Ruff. Okay, so it's letter A. So 7 halves is 3.5. I think I said it too fast. You guys wonder what was going on there. All right, and then, hey, input, say it, output, input, output, input, output, input, output. What are these outputs being confined to? What number? 7 over 2. So what letter is that? This one. Got a crinkle, crinkle. Drink time. V. It's like freezing in here. It's not the Sahara Desert. All right. Anyway, next. Okay, x equals 0, and then we got a slant asymptote. What's the only one that's slanted and how it ends? Which letter? C. Okay, so this is going to be C, but I'll prove it. And then I had to zoom in on this. That's 5 right there, right? So y equals 2. All right, there's that y-intercept, correct? Doesn't it go up to 5, right? Goes by 5s. But then I have to rise 2 and run 1. That's about rising 2 and running 1. Okay, and this is kind of tough to do with a scale that's like this. But we can see that this graph seems to be confined by some linear scenario. When this actually happens, when we're going to go ahead and look at our graphing calculator on this stuff, we'll get to analyze that asymptote pretty good. Hey, but also look at this, x equals 0. And you can see how the graph is confined by that, right? And then our third page, we'll talk about those limits. That's why we weren't ready for formative and all this other stuff. So C is the graph there. And then what are my limits? As x goes to infinity, where is y going? Where's y going? Infinity. And as x goes to negative infinity, as I input that, where are my outputs going? To what? Negative infinity. So I'm crushing through some other graphs here, but I'll be all right. All right, so that is letter I, right? Correct? Correct. That's I. Got it? So at least this is giving you an idea of how these graphs shake out. How do I know these pictures look like this? Just wait, okay? Just be patient on that one. Okay, y equals 0, and then I have a hole at 5, negative 1/10. Which letter is that? What do we have left, B, E, or F? Which one has a hole at 5, F, or no, I'm sorry, B. No, that's not 5. Who said F? All right, anyway, you threw me off and you embarrassed me on the video. It's B. Did it on purpose. Okay? It's B. Look at that. 5, and it almost looks like it's at 0. And by the way, yeah, y equals 0 is the horizontal asymptote, and x equals negative 5 is the vertical asymptote. So it all fits. This pen's really bad. You should make your asymptotes dotted lines. This isn't letting me do the dotted line too nice. So anyway, that's B. And then input, say it. As I input infinity and negative infinity, those outputs are going to 0. That's the whole point of the horizontal asymptotes and behaviors. All right, so I'm crossing these out when I'm done as a process of elimination. All right, and then we'll speed it up here. X equals 1, y equals negative 3. X equals 1, y equals negative 3. X equals 1, y equals negative 3. And then I do have a hole at negative 1, 3. So this is letter F. All right, and then input, say it. When I input big numbers for x, both negative and positive, I'm going to that horizontal asymptote. So that is 4. Well, I shouldn't say 4. I'm thinking of Roman numerals here. And then that leaves me these last ones, which makes sense. Who's left? E. This is E, and this must be 3. But it is x equals negative 3, x equals negative 3, y equals 0. And then, of course, the limits approach 0 on the ends. Right? All right. So I got to close that off. That only works on the video because of the way this sheet works. And then all this you can read. We're running out of time. There's a lot of stuff expected here, but it is true how we're going to write these limits. And they tried to shove this at you yesterday, and I refused to because I knew we had to spend a day on this. But maybe highlight this. Where did my regular pen go? Did I leave that right here? Uh-oh. Where did I put my pen for the actual? Here it is. Get your highlighter out real quick if you care. This notation, which they tried, we're going to do yesterday. I'm like, we're not ready. That means I'm coming from the left of an x value. The notes yesterday were great with those charts on the bottom where you had an x value. Let's say it was like 2 input output. They showed the output was undefined. Then right before it, 1.99, 1.99, 1.9. And they showed those crazy outputs. And one of them I actually analyzed with you. And then on the other side, 2.001, 2.01, 2.1. And they showed as you got closer and closer, these values got nuts. Well, you should be able to look at that in a graph, and that's what I'm going to do right now. So that's what these mean. When you have a k negative, that doesn't mean k is negative. It means I'm approaching it from the left side. And k positive means I'm approaching it from the right. This is more the same about end behavior, and so on and so forth. All this stuff I'm going to go over. You want to read this stuff, go for it. So here's what we're going to do. I'm just going to do this, but I'm not really going to state them. I guess I could on the first one. I think the last class I was only able to do number one because they're asking you a lot of stuff about each question. So state the vertical, state the horizontal or slant. C is slant, D is limit for end, E is limit around the verticals. Remind me of that. So number one, on this first one, we got a factor and we got no time. I got no time to wait. 2x and 1x, and I'll go through my thought process that I had with the other class. Kind of suspicious that I think it's 3 and 5, not 1 and 15, because my middle number is kind of in the smaller range, -7. So 3 and 5. I know 10 and 3 differ by 7. That's why I put 5 here, because I know I'm going to end up doing 2 times 5. Good foiler, say it. I'm doing the foiling thinking. And then this has to be the 3 because there I have 10x and 3x. Those differ to be 7. Who gets the negative, 5 or 3? 5. You guys are good with factoring. I don't know what it is. It's a numeracy problem. I think in my ABers, they just can't, they don't know how to multiply numbers. It's got to be the problem. I don't know why factoring is such a big deal. But anyway, this is why we see x equals 5. X equals 5 and x equals negative 1.5, which I kind of have to squeeze that in there. And that's what this is why I didn't write it in the other one. That's letter A. That's what we were supposed to write right there. But I like writing it there. And then look at the numerator and denominator degrees. This is a rule. This is why I lament about teaching this Monday, Tuesday, Wednesday, Thursday, Friday, and then talking about it again at Monday, 6 days in a row with those students. And I still have people that can't tell me y equals what. What's the answer for B? Y equals 0. Because when I input big numbers, the outputs turn into 0. The y is already done. You need to remember and lock it in. And I'm not taking 6 days, not like the ABers. Okay, we've got to do the job. What does it say about C? Well, if I have a horizontal, I don't have a slant. It's one or the other. Okay, now end behavior. This is what we're going to be able to do now. And this is where it gets a little small to do here. All right, so yeah, I don't know. I'm thinking about writing up here again, but no, then I'd have to move the thing. So the limit of f of x as x approaches negative infinity. Well, this is 100% related to these two, B and D. They're linked. It's the whole point of the horizontal asymptote. It's telling me what the outputs are. When I plug in negative infinity, what do I get for an output? 0. It's the same number. And then the limit of f of x. It's hard to write when this is so small. I wrote that wrong too. My brain's hurting from the size and what I'm dealing with these notes here. X approaches infinity, and that's 0 as well. This is why I don't have time to probably go to 2 and 3. I'll probably just have to verbalize it because we're almost, we have 7 minutes left. You know how many limits I have to do in letter E? How many vertical asymptotes are there? 2. How many limits am I going to have to do? 4, because I have to go left and right of each one of these. So you can look at the picture up there. I'll label it. I got it memorized. So the first asymptote was -3/2. So as x approaches -3/2 negative, those negatives don't cancel. Those mean two completely different things. This means I have a negative number. This means I'm going to the left of that. I almost said right on accident. Okay, when I jump to the left of this, let's zoom right in here and then point. Hopefully you can see. Here's 3/2 negative. When I jump just left, input, say it. Outputs, it's way down here. What is that number way down there? Oh, this makes me sad. And I yelled at my students. We had a quiz today, and I had like 50% people get this wrong. And I'm like, good Lord, you're going to miss like easy points on our coming quiz Thursday. Not you guys. AB has a quiz Thursday. Did you get scared on that? Limit of f of x as x approaches -3/2 positive. Let's go back up to the graph. Let's look at that. And then let's write it right here. Here's 3/2. Here's right of 3/2. Input, output. Get closer, output. Closer, output. Where are these outputs going? Infinity. How is this hard? Oh, my kids in that class. Oh, I just don't. What's 5 negative mean? 5 from the left. So I look at my graph. Here's 5. Here's plugging in just left of 5. Input, output. Get closer, output. Get closer, output. Where are these outputs going? How is that hard? The answer, it's not. Now, what's the last answer? I'm not going up there. What's the answer? Infinity. Okay, so that means, this in theory means, hey, what happens if I plugged in 5.000001? Input, say it. That's what that means. This means if I plugged in 4.999999, do you want me to stop? 99, okay, just a little bit left of 5. That's what that means. And then you had those on that charts yesterday. Remember that? I don't feel like doing the others, but I could verbalize. Hey, what kind of asymptote does this have? Slans. Okay, you'd have to physically divide those two. So these, as I plug in infinity for x, where does y go? And as I plug in negative infinity, where does y go? In negative infinity, right? So you got to watch out on those. You just have to look at the picture. Vertical asymptote would be x equals 2/4, which is 1/2. And then 1/2 left and right. Left of 1/2 infinity, right of 1/2 negative infinity. You guys are in honors A, B, C. You can figure this out. This is a weird one though. When this factors, I do want you to kind of see this. Because that vertical asymptote is squared, you don't have enough knowledge about rational functions, but that's a strange one, how they're both down like this. It's because of that squared bottom there. But I do have x equals, y equals 0 for a horizontal asymptote. Another strange thing that happens is this horizontal asymptote's actually crossed. So what this graph does is it crosses through and then approaches from the other side. So it's still approaching that end there. I just wanted to exaggerate that a little bit more so you could see that in the picture. So you gotta trust your eyes, what you see there, as far as what's going on there. So anyway, I do have y equals 0 as a horizontal asymptote, so that's what the limits would approach, both negative infinity and positive infinity. You'd have 0. And then, hey, just -2 to the left, where's y going? -2 to the left? Negative infinity. But then -2 to the right, where's y going? Both of them are negative infinity. So we can verbalize those at least. So that was a lot. Can you imagine if we did a formative and then did an intro? I don't know how they do it sometimes. I don't know where they fit the time in.